Most people worry about what they eat, but very few stop to think about what happens to food after it has already been cooked. Every day, millions of families open the refrigerator, take out yesterday's dinner, warm it for a few minutes, and assume it is just as healthy as it was the first time it was served. The surprising reality is that food does not simply pause while it sits in the refrigerator. Even at cold temperatures, tiny chemical changes continue taking place inside proteins, fats, and carbohydrates. When that same food is heated again, some of those changes can accelerate, creating entirely new compounds that were not present when the meal was freshly prepared. Now, before we go any further, I want to make something very clear. This is not a reason to panic every time you eat leftovers. Leftovers can absolutely be part of a healthy lifestyle when they are stored correctly and handled safely. The purpose of today's discussion is something much more practical. I want you to understand which foods deserve extra attention, why scientists continue to study them, and how a few simple habits may help reduce unnecessary exposure to compounds that researchers have linked with long-term health concerns. As a physician, I have spent years studying how nutrition influences the body's natural defense systems. One lesson appears again and again throughout modern medical research. Health is rarely determined by one dramatic decision. Instead, it is shaped by thousands of small choices repeated over months and years. The foods we select, the way we prepare them, how we store them, and yes, even how we reheat them. When researchers investigate chronic diseases, they rarely find a single cause. Cancer, cardiovascular disease, diabetes, and neurodegenerative disorders all develop through complex biological pathways involving genetics, environmental exposure, inflammation, metabolism, and lifestyle. Food is only one piece of that puzzle, but it is one piece we can actually influence every single day. That is why nutritional science continues to evolve. Scientists are no longer asking only whether a food contains enough vitamins or protein. Today, they also study what happens to food molecules during cooking, refrigeration, freezing, reheating, and digestion. These questions matter because the chemistry of food does not stop the moment dinner is finished. Heat changes food. Time changes food. Oxygen changes food. Even the natural bacteria that live harmlessly around us can influence the chemistry of stored meals. Sometimes those changes are beneficial, sometimes they have little effect at all. But in certain situations, repeated heating may encourage reactions that scientists believe deserve greater attention. That is exactly what we are going to explore together. Throughout this series, I will introduce 4 foods that appear in kitchens around the world almost every day. Most people consider them healthy choices, and in many situations, they absolutely are. The concern is not the food itself. The concern is how repeated storage and reheating may influence its chemistry. Understanding that difference is incredibly important. Too often, health information online creates unnecessary fear. One article claims a food is dangerous. Another claims it is a miracle. The truth is almost always more balanced. Dose matters. Preparation matters. Frequency matters. And context matters. That is why I prefer to focus on evidence instead of headlines. Rather than asking whether a food is good or bad, I ask a different question. What actually happens inside that food as it moves from the stove to the refrigerator and back to the microwave or oven? To answer that question, we first need to understand 3 simple biological processes that appear repeatedly throughout food science. The first is oxidation. You have probably seen oxidation before without realizing it. An apple turns brown after it is sliced. Avocados darken when exposed to air. Cooking oils eventually develop an unpleasant smell after sitting too long. These are all examples of oxidation. Inside cooked food, oxygen slowly reacts with fats and proteins. Each reaction creates small molecular changes. Most are harmless, some are not. Repeated heating may speed up these reactions, especially in foods rich in delicate fats. The second process involves advanced glycation products, often called AGEs. Despite the name, this has nothing to do with getting older. These compounds form when proteins and natural sugars are exposed to heat. The same reaction gives grilled meat its rich aroma and toasted bread its golden color. In moderation, this is simply part of cooking. However, repeated high-temperature heating can increase the production of these compounds. Researchers continue investigating whether excessive dietary exposure may contribute to chronic inflammation, which plays an important role in many diseases, including cancer and heart disease. The third process involves nitrogen-containing compounds naturally found in certain foods. Under specific storage conditions, these molecules may gradually change into different chemical forms. If those foods are heated again, additional reactions can occur that scientists continue to study because of their potential health implications. These mechanisms sound technical, but the practical message is remarkably simple. Food chemistry continues even after dinner is over. Every trip from the refrigerator back to the microwave gives those molecules another opportunity to change. That does not mean every reheated meal is dangerous. It means some foods deserve more careful handling than others. During the next few sections of this discussion, we will examine 4 familiar foods that many families prepare every single week. Some of the findings may surprise you. Not because these foods are unhealthy, but because the way we commonly store and reheat them may not always be the safest approach. The goal is not perfection. The goal is awareness. Because once you understand the science, making better choices becomes much easier. And the first food on our list is probably sitting in your kitchen right now. It is one of the most widely eaten foods on Earth, served in billions of meals every single day, yet very few people realize what can happen to it between the first serving and the second. The first food I want to talk about is rice. If you ask people around the world what food they eat most often, rice would be near the top of the list. It feeds billions of people every single day. From Asia and Africa to Europe and the Americas, rice has become one of the most dependable staples in human nutrition. It is affordable, versatile, easy to prepare, and when paired with vegetables, beans, seafood, or lean proteins, it can be part of an exceptionally healthy diet. The concern, however, is rarely the freshly cooked rice. The concern begins after the meal is over. Picture a typical evening. And dinner ends, the remaining rice is left on the counter for a while, then eventually transferred into a container and placed in the refrigerator. The next day, it is reheated in a microwave or on the stovetop and served again. This routine feels completely normal. In fact, millions of households follow it every single day without giving it a second thought. But from a scientific perspective, quite a lot has already happened before that second heating ever begins. One of the most important concerns involves a naturally occurring bacterium known as Bacillus cereus. This microorganism is surprisingly common. It exists in soil, dust, and agricultural environments, which means tiny spores can naturally be present on raw rice before it is even harvested. Unlike many bacteria, these spores are remarkably resistant. Cooking destroys the active bacteria, but the spores themselves can survive the temperatures normally used to prepare rice. That does not automatically make the food unsafe. The real issue depends on what happens afterward. If cooked rice remains at room temperature for too long, those surviving spores may begin to awaken. As temperatures become favorable, they can multiply and produce toxins. Some of these toxins are unusually stable. Even if the rice is reheated thoroughly the following day, the bacteria themselves may be reduced, but certain toxins can remain. This is why food safety experts consistently recommend cooling cooked rice quickly and refrigerating it as soon as possible rather than allowing it to sit out for hours. Food safety organizations around the world emphasize that proper storage is every bit as important as proper cooking. Yet there is another layer to this story that receives much less attention. Scientists are increasingly interested in how repeated heating changes the chemistry of starchy foods. Rice is primarily composed of starch. During cooking, those starch granules absorb water, swell, and change their physical structure. As the rice cools, some of that starch reorganizes into what researchers call resistant starch. This is actually a beneficial process because resistant starch can support gut bacteria and improve metabolic health. However, when rice is heated repeatedly at high temperatures, additional chemical reactions begin to occur. Researchers have investigated whether repeated exposure to high heat may encourage the formation of compounds such as acrylamide under certain cooking conditions, particularly when foods become excessively browned or dehydrated. Acrylamide has attracted scientific attention for many years because laboratory studies have shown that high levels can damage cells and genetic material. International health agencies continue to classify it as a probable human carcinogen based on the available evidence. It is important to keep that information in perspective. The amount produced depends on several factors, including temperature, cooking method, moisture, and duration of heating. Not every reheated bowl of rice contains significant amounts. But understanding the conditions that increase its formation allows us to make smarter decisions. Another fascinating area of research focuses on oxidative stress. Every cell in our body constantly balances molecules known as free radicals with protective antioxidant systems. When this balance is disrupted over long periods, oxidative stress can contribute to chronic inflammation and cellular damage. Some compounds produced during repeated heating may increase this oxidative burden, particularly when foods are exposed to very high temperatures over multiple cooking cycles. Again, this is not about one meal. Cancer does not develop because of yesterday's lunch. Scientists study these processes because chronic diseases usually result from cumulative exposure over many years. Small habits repeated thousands of times deserve attention because they slowly shape our internal environment. Fortunately, reducing unnecessary risk is remarkably simple. If you prepare rice, cool it promptly, rather than leaving it on the kitchen counter. Store it in shallow containers so the temperature drops more quickly. Keep it refrigerated. Plan to eat it within a day whenever possible. And instead of reheating the same batch multiple times, warm only the portion you intend to eat. That single adjustment can significantly reduce both microbiological and chemical concerns. These recommendations are not complicated. They do not require expensive equipment or dramatic lifestyle changes. They simply reflect what decades of food safety research has taught us about minimizing unnecessary risk. Now let's move to another food that almost everyone considers a symbol of healthy eating. Whether someone is trying to lose weight, build muscle, or simply eat a balanced diet, this food is almost always on the menu. Doctors recommend it. Dietitians recommend it. Athletes prepare it by the kilogram for weekly meal plans. Families cook it for quick dinners throughout the week, and nearly everyone reheats the leftovers without hesitation. What most people don't realize is that proteins behave very differently from carbohydrates when they are exposed to heat again. In fact, the chemistry becomes considerably more complex. That is exactly where our next discussion begins. Chicken has earned a reputation as one of the healthiest sources of protein available. If you visit almost any nutrition clinic, fitness center, or hospital, you will find chicken included in meal plans designed to support weight management, muscle maintenance, and overall metabolic health. It is naturally rich in high-quality protein. It contains essential amino acids that help repair tissues, support immune function, and preserve muscle as we age. Freshly cooked chicken can absolutely be part of a healthy, balanced diet. The concern is not the chicken itself. The concern is what can happen when cooked chicken is repeatedly exposed to high temperatures. Proteins are remarkably complex molecules. When you cook chicken for the first time, heat unfolds the protein structure in a process known as denaturation. This makes the meat easier to digest and allows digestive enzymes to access nutrients more efficiently. That is a normal and beneficial part of cooking. However, Once those proteins have already been altered by heat, placing them back under high temperatures does not simply repeat the same process. Instead, additional chemical reactions begin to occur. One of the most carefully studied involves protein oxidation. During refrigeration, oxygen slowly interacts with proteins and fats inside the cooked meat. These changes are gradual and often invisible. The chicken may look perfectly normal. It may smell completely fresh. Yet on a molecular level, oxidation continues. When that same chicken is reheated at high temperatures, particularly until it becomes very hot or begins to brown again, oxidative reactions can accelerate. Researchers have found that this process may contribute to the formation of compounds called heterocyclic amines, commonly abbreviated as HCAs. These compounds have been investigated extensively in nutritional science. They are produced when amino acids, natural sugars, and creatine, found in muscle tissue, react under intense heat. The higher the temperature and the longer the exposure, the greater the opportunity for these reactions to occur. HCAs have attracted attention because laboratory studies have shown that after they are metabolized by the liver, some can interact directly with DNA. DNA serves as the instruction manual for every cell in the body. When its structure is damaged, cells usually repair themselves remarkably well. Our bodies possess sophisticated repair systems that work continuously. But if damage accumulates faster than it can be repaired over many years, mutations may gradually develop. Some mutations are harmless. Others affect genes responsible for controlling normal cell growth. This is one of the biological pathways scientists investigate when studying the development of cancer. It is important to emphasize that no single meal determines your future health. The body is incredibly resilient. It constantly repairs damage, removes abnormal cells, and protects itself through powerful antioxidant defenses. The concern lies in repeated exposure over long periods. Health is influenced by patterns rather than isolated events. That is why researchers focus on lifestyle habits instead of individual meals. Another important process involves lipid oxidation. Although chicken is considered lean, it still contains fats, especially in the skin and darker meat. When these fats are exposed to oxygen during storage and then heated again, they can break down into secondary oxidation products. Among the compounds scientists frequently study are malondialdehyde and 4-hydroxynonenal. Both have been associated with oxidative stress and inflammation in experimental research. Inflammation itself is not harmful. In fact, it is one of the body's most important healing responses. The problem arises when low-grade inflammation persists for years. Chronic inflammation has been linked to numerous diseases, including cardiovascular disease, metabolic disorders, and several forms of cancer. That connection explains why researchers pay close attention to foods that may increase the body's overall inflammatory burden. Fortunately, reducing these reactions is often easier than people imagine. Instead of reheating chicken until it becomes steaming hot or develops a second brown surface, use gentle heat whenever possible. Warm only the portion you plan to eat. Avoid repeatedly heating and cooling the same container over several days. If the chicken has already been reheated once, it is generally better to finish it rather than refrigerating it again for another cycle. Another excellent option is to enjoy leftover chicken without reheating it at all. Cold chicken can be added to fresh salads, whole grain wraps, vegetable bowls, or homemade sandwiches. This approach not only preserves texture, but also reduces additional heat exposure that encourages unwanted chemical reactions. Simple adjustments like these can make a meaningful difference over time. Now I want to move to a food that surprises almost everyone when they first hear the science behind it. Unlike chicken, this food is often celebrated specifically because it is packed with vitamins, minerals, antioxidants, and plant compounds that support long-term health. Doctors encourage patients to eat more of it. Nutrition experts praise its role in protecting the heart. Researchers continue discovering new benefits associated with its natural compounds. in its fresh form, it truly deserves its reputation as one of nature's healthiest foods. Yet, under certain storage and reheating conditions, its chemistry can change in ways that many people have never considered. The transformation involves naturally occurring nitrates, bacterial activity, and a sequence of reactions that scientists have studied for decades. Understanding this process may completely change how you think about preparing leafy vegetables for meal prep. And that is exactly where we will continue in the next part. There is another category of food that often surprises people during conversations like this because it has one of the healthiest reputations in nutrition. When most of us think about protecting our heart, supporting healthy blood pressure, or reducing the risk of chronic disease, leafy green vegetables immediately come to mind. Spinach, Swiss chard, beet greens, celery, and similar vegetables are packed with vitamins, minerals, fiber, and plant compounds that help the body defend itself against inflammation and oxidative stress. Countless scientific studies have associated regular consumption of these vegetables with better cardiovascular health, improved metabolic function, and a lower risk of several chronic illnesses. Freshly prepared, they truly deserve their place on a healthy plate. The concern is not whether you should eat them. The answer to that question is still yes. The real question is whether repeatedly storing and reheating these vegetables changes some of the chemistry that originally made them beneficial. This is where food science becomes especially interesting, because the answer depends less on the vegetable itself and more on what happens after it has been cooked. Many leafy greens naturally contain compounds called nitrates. Despite what you may have heard online, naturally occurring nitrates found in vegetables are not inherently harmful. In fact, they play an important role in human health. Inside the body, nitrates can be converted into nitric oxide, a molecule that helps blood vessels relax, improves circulation, supports healthy blood pressure, and even enhances oxygen delivery to muscles during physical activity. These are positive biological effects that explain why nutrition experts continue recommending vegetables rich in natural nitrates. However, once these vegetables are cooked and stored, another process begins. Even inside a refrigerator, naturally occurring bacteria can slowly convert some of those nitrates into nitrites. This conversion is influenced by time, storage conditions, temperature, and bacterial activity. On its own, this process does not necessarily create a dangerous food, but it does change the chemical environment inside those vegetables. When the vegetables are later exposed to another round of high heat, additional reactions become possible. Under certain conditions, nitrites can interact with naturally occurring amino compounds to form molecules known as nitrosamines. These compounds have been the subject of extensive scientific research because several members of this chemical family have demonstrated carcinogenic properties in laboratory studies. Researchers continue investigating the relationship between long-term dietary exposure and human cancer risk, particularly involving cancers of the digestive system. One reason this topic receives so much scientific attention is because nitrosamines have been detected in multiple food categories under specific processing and cooking conditions. They are not unique to vegetables, nor do they automatically appear every time spinach is reheated. The amount depends on numerous variables, including storage duration, temperature, moisture, and preparation methods. That distinction is extremely important because health information often becomes misleading when complex science is reduced to simple headlines. The goal is not to convince people that spinach has suddenly become dangerous. Quite the opposite. Spinach remains one of the most nutritious foods available. The practical lesson is simply that some vegetables are best enjoyed fresh or eaten soon after cooking rather than repeatedly reheated over several days. This allows you to benefit from their outstanding nutritional value while minimizing unnecessary chemical changes that scientists continue to investigate. It is a balanced approach supported by both nutrition and food safety principles. If you prepare leafy greens as part of your weekly meals, there are several easy habits that can help preserve both quality and safety. Cook only the amount you expect to eat whenever possible. If leftovers remain, cool them promptly and refrigerate them without unnecessary delay. Try to consume them within a relatively short period rather than allowing them to remain in storage for several days. Many people enjoy cold spinach in salads, grain bowls, or wraps the following day, which avoids another heating cycle altogether. These are not difficult changes, yet they reflect the way food chemistry actually works. The less stress we place on delicate food molecules through repeated heating, the more closely the meal resembles its original nutritional profile. Small adjustments like these fit perfectly within an overall strategy of preventive nutrition, where long-term health is built through consistent everyday decisions rather than dramatic dietary restrictions. Now we arrive at perhaps the most unexpected food on today's list. It is a food recommended by physicians, dietitians, athletes, and researchers alike. It delivers complete, high-quality protein. It provides essential amino acids required for tissue repair. It is one of the richest natural sources of choline, a nutrient critical for brain function and nervous system health. It supplies selenium to support antioxidant defenses, along with lutein and zeaxanthin, compounds that help protect vision as we grow older. By nearly every nutritional measure, eggs deserve their reputation as one of nature's most complete foods. Yet even this nutritional powerhouse undergoes measurable chemical changes after cooking, refrigeration, and repeated heating. The explanation involves cholesterol oxidation, delicate fats found within the yolk, and changes in protein structure that many people have never heard discussed outside scientific journals. Understanding those reactions does not mean avoiding eggs. It simply means learning the smartest way to prepare, store, and enjoy them so you continue receiving all of their remarkable nutritional benefits while limiting unnecessary exposure to compounds that may not serve your long-term health. That final piece of the puzzle is exactly where we'll begin in the last part of this series. The final food on our list is one that surprises almost everyone because it has long been considered one of the most complete foods available. Eggs have earned that reputation for good reason. They provide all 9 essential amino acids, making them an excellent source of complete protein. They contain choline, a nutrient that plays a critical role in brain development, memory, and healthy nerve function. They also provide selenium, vitamin B12, vitamin D, and antioxidants such as lutein and zeaxanthin that help support eye health and protect cells from oxidative damage. From a nutritional standpoint, eggs deserve their place among the healthiest foods we can eat. The concern is not about eating eggs. It is about understanding how repeated heating changes their chemistry after they have already been cooked. This distinction is essential because the goal of preventive nutrition is not to eliminate healthy foods, but to prepare and consume them in ways that preserve their nutritional value while minimizing unnecessary chemical changes. When an egg is cooked for the first time, heat unfolds its proteins into structures that are easier for our digestive system to process. This is a completely natural and beneficial transformation. The fats found in the yolk also undergo mild oxidation, which is expected whenever foods containing lipids are exposed to heat. Problems begin when the same cooked egg is refrigerated and later subjected to another round of high-temperature cooking. During storage, oxygen continues interacting with fats inside the yolk. Although these changes are invisible to the eye, they continue gradually over time. Once high heat is applied again, oxidation accelerates, creating additional compounds that researchers continue to study because of their biological effects. Among these are oxidized cholesterol derivatives, often referred to as oxysterols. These molecules have attracted increasing attention in nutritional science because laboratory studies suggest they may contribute to inflammation, oxidative stress, and damage to cells when present in excessive amounts over long periods. Scientists continue investigating exactly how these compounds influence chronic disease, but there is enough evidence to encourage moderation in the way cholesterol-rich foods are repeatedly heated. The proteins inside eggs also deserve attention. During a second heating cycle, especially when eggs are microwaved rapidly or cooked until they become rubbery and dry, protein structures continue changing beyond the initial denaturation that occurred during cooking. Excessive heat may encourage additional cross-linking between protein molecules, making them more difficult for digestive enzymes to break apart. Some researchers also believe that repeated heating may influence sulfur-containing amino acids naturally present in eggs, contributing to increased oxidative activity within the digestive tract. While these effects are still being explored, they reinforce a broader principle that appears repeatedly throughout food science. Foods generally maintain their best nutritional quality when they are cooked once, stored safely, and reheated gently if reheating is necessary at all. Every additional cycle of intense heat creates another opportunity for nutrients to degrade and unwanted byproducts to accumulate. At this point, you may be wondering whether all leftovers should simply be thrown away. The answer is no. That is not the message of today's discussion. Leftovers remain an important part of reducing food waste, saving time, and maintaining healthy eating habits. The message is far more balanced than that. The science encourages us to think carefully about how we handle food after it has been cooked. Cool meals promptly, rather than leaving them at room temperature. Store them in clean, airtight containers. Refrigerate them quickly. Reheat only the portion you intend to eat, instead of warming the same container repeatedly. Use gentle heat whenever possible, instead of exposing food to unnecessarily high temperatures. Plan meal sizes so fewer leftovers remain. These are simple habits, yet together they reduce both food safety concerns and the chemical changes associated with repeated heating. Preventive medicine often works this way. The greatest benefits usually come from small decisions repeated consistently over many years rather than dramatic changes made only once. Now let's bring everything together. Today we explored 4 foods that appear on millions of dinner tables every day. Rice reminded us that proper cooling and storage are just as important as proper cooking, because bacterial toxins can survive even after reheating, while repeated exposure to high temperatures may also encourage the formation of unwanted compounds under certain conditions. Chicken demonstrated how repeated heating of animal proteins can increase oxidation and promote the formation of heat-related chemicals that scientists continue studying for their effects on DNA and long-term health. Leafy green vegetables showed us that naturally beneficial nitrates can undergo additional chemical transformations during storage and reheating, reminding us that even the healthiest foods deserve thoughtful preparation. Finally, eggs illustrated how repeated heating may accelerate cholesterol oxidation and alter delicate proteins in ways that are still being actively investigated by researchers around the world. Although each food follows a different biochemical pathway, they all point toward the same conclusion. The chemistry of food continues long after cooking has ended. Heat, oxygen, storage time, and repeated reheating all influence what ultimately reaches our cells. Perhaps the most important lesson from today's discussion is that knowledge empowers better decisions rather than unnecessary fear. Your body is incredibly resilient. Every day it repairs damaged cells, neutralizes free radicals, removes abnormal proteins, and protects itself through sophisticated defense systems that have evolved over millions of years. Our goal is not to become afraid of every meal. Our goal is to reduce avoidable stress on those protective systems whenever we reasonably can. Science rarely asks us to pursue perfection. Instead, it encourages steady improvement through informed choices, preparing fresh meals more often, reheating foods only when necessary, using moderate temperatures, and avoiding multiple reheating cycles are practical habits supported by both food chemistry and common sense. They cost nothing, require no supplements, and fit naturally into everyday life. Before we finish, I would like you to think about your own kitchen. Which of these 4 foods surprised you the most? Was it rice, because it seems so harmless? Was it chicken, the protein so many people rely on for healthy meal preparation? Was it leafy greens, which are almost universally recommended by nutrition experts? Or was it eggs, one of nature's most complete foods? I would genuinely enjoy hearing your thoughts, because your experiences and questions often inspire future discussions. If there is another food you prepare regularly and would like to understand from a scientific perspective, let me know. Nutrition science is constantly evolving, and there are many everyday habits worth exploring with the same evidence-based approach. If you found this discussion valuable, consider sharing it with someone you care about, perhaps a parent who regularly reheats leftovers, a college student preparing meals for the week, a busy professional trying to save time, or a friend committed to eating healthier. Sharing reliable information is one of the simplest ways we can support one another's health, not through fear, but through education. Small improvements made by many people can have an enormous impact over time. Finally, I want to leave you with one important reminder. Everything discussed in this video is intended for educational purposes and is based on current scientific understanding. Nutrition research continues to develop, and recommendations may evolve as new evidence becomes available. Individual health needs also vary depending on age, medical history, medications, and underlying conditions. Always consult your physician or a qualified healthcare professional before making significant dietary changes, especially if you have existing medical concerns. My goal has never been to replace your healthcare provider or create unnecessary worry. It is simply to help bridge the gap between scientific research and everyday life so that you can make informed decisions with confidence. Thank you for spending this time with me. I truly appreciate your trust, and I look forward to continuing this journey of evidence-based nutrition with you in our next discussion. Until then, take care of yourself, take care of those you love, and remember that every healthy choice you make today is an investment in the years ahead.